Now we're going to graph a radical. Again, these are going to be a little bit more harder. And then we have a cubic that we'll graph. So see how you did? So I know that the parent function does the 1, 1, or the 0, 0, 1, 1, 4, 2. When we did quadratics, it was the other way around, right? It was 0, 0, 1, 1, 2, 4. Now it's 4, 2. So the whole thing is flipped on the side. Okay, excuse me, sorry. So what we're going to do is I'm going to draw in a light color the parent function after the transformation. So we've gone over to the right 2, and we've gone up 3, right? Okay. So I'm going to just draw. Now what I'm doing is I'm ignoring the -4 for a second. And I'm just moving to that location, okay, to the up and down, right or left. So once I move there, I got 1, 1, and then 1, 2, 3, 4, 2. Okay. But now that I have this thing, this does change the game quite a bit. The negative sign is going to force all of my outputs to actually go in the other direction. Okay, so everything starts to decrease instead of everything increasing gradually. Everything will now decrease gradually. So I'm going to start here, but now instead of going 1, 1 going downwards because of the negative, I have to quadruple that 1 value. I have to multiply. So these are sometimes called multipliers. So when I go, instead of going 1, I'm going to multiply by -4 to give me 1, 2, 3, 4. 4 going down. 1, 2, 3, 4. Sorry, I missed it. 1, 2, 3, 4. Right. Okay, so it's not this guy. It's this guy. Now when I go over to 4, 1, 2, 3, 4, I should only go here, but now I have to multiply that distance by -4, and that'll give me 1, 2, 3, 4. There. Okay. Now it should look like a gradual curve, and if it doesn't, then something's wrong. Like if it was going this way and you went too far, you'll be able to see it. It's like it doesn't look like a hook, so something's wrong. Okay. But that's what -4 does to the parent function there. All right, now cube root actually will look like kind of like an S shape, okay, or a propeller shaped. So we're going to move it, and it's got a multiplier, so we'll see how that goes. We're going to move it to its location, and I'm going to do this in red, this light red. I'm going to go to the right 1 and then up 3, so 1, 2, 3. So now I'm here, okay, and normally I would just go 1, 1 and 1, 1. Now, believe it or not, that is enough. Like, I can just draw. Now, these guys get flat pretty quick, because if I were to go to my next one, it would probably, well, it's definitely going to take me off the graph. I think. No, actually, I can. So from here, I think it actually goes here. It does actually reach. Yeah, so it does go all the way there. So it's quite flat, really. But that's just without the +2. So what does the 2 do? Well, it's going to multiply those distances, those y distances from the center of the function, the parent function. It's going to move them. It's going to double that distance. So now instead of just going up 1 from the center here, that's the center, instead of going up 1, you're going to go 2. Instead of going up 2 over here, you're going to go 4. Okay, so that gives it a larger propeller instead of 1, 2, and we're going to double that. Okay, now it should look nice and symmetrical. Okay, so some of you are kind of, when you're doing, you're like just all like, it should look smooth. So try. No, I'm exaggerating. You're not that weird, but you know, you kind of your curves kind of like will kind of go up and down, but that's a polynomial. You just want one smooth curve. Okay, that's an exaggeration. Okay, 25. Got two functions labeled f and g, and we want to find their product. So this means then that I just simply take 3x plus 3 as f, x plus 1 as g, and I will just multiply them. Alright, now this x here means actually nothing because its input is x, but that's all was already given to us. All right, so it's no big deal at all. We're going to multiply these out. 3x squared plus 3x, and then 3x again, and then 3 times 1 is 3. So we've got 3x squared plus 6x plus 3, and that's d. All right, so we just multiply it out. We're not plugging in a number. We're not doing anything. All right, now here's another way to write this. This is kind of this is probably what makes a little bit more sense instead of this, but you know, same thing. We're just now subtracting the two functions. So if I had x minus 2, I'm going to subtract the h function. Okay, but I just want to show you that this right here is actually wrong. So be very careful, because this is easy to do. When you subtract the h of x, you are subtracting both of them. Both, or I should say, the entire function. So here, the negative sign we only applied to the 2, but we didn't actually apply it to the 5 because he was already negative. So you want to distribute the negative sign. So we could have written it like this just to be safe. Okay, and then distribute the negative sign. Okay, either way, this is going to give you this result. So it looks like we're ready to kind of combine these now. We are left with a negative 2x squared. Now I'm just putting the higher degree terms in the front, and then the next one should be x's. So that's a 6x, positive 6x, and then we're left with a negative 2, and so that is negative 2x. Looks like that's going to be b. All right. What do we got? We got 4 more. All right, we'll stop here.